Welcome, everyone. Appreciate everyone joining us today. Uh, we all know that everyone's time is valuable, but we do appreciate the opportunity to present what should really be a very interesting discussion today, brought to you by Mesa. Title of our webinar for today, and we'll spend about an hour discussing with the group assembled here. Tomorrow's manufacturing, how to power your industrial transformation with emerging technology. So with me, presenting today is Jill Klein. Jill Klein is the head of emerging technology and IoT at CDW. Jill has over 2 decades of experience at leading teams, um, and and in addition to her role at CDW, Jill is a CompTIA member champion, recognized for her leadership and advocacy in advancing technology, industry, and workforce development. Jill served as the chair of both the CompTIA Advisory Council and the Data Advisory Council, roles that showcase her leadership and expertise, ultimately qualifying her for recognition in CompTIA's member as a CompTIA member champion. Now, in addition to Jill, and she leads up the head of emerging technology and IoT at CDW, she has a powerhouse of team members and SMEs, and with her is Oscar De Leon. He is a strategist in this group, and he's going to support her in this webinar. Jill, if you could switch to the next slide, please. I'm Chris Monchinsky. I'll be your moderator today. I lead up the Mesa Knowledge Committee. The Mesa Knowledge Committee is a committee within Mesa that really, I always say, is responsible for the curation of all the content that we create and provide to our members in Mesa. This includes things such as this webinar today, but also includes white papers, blog posts, interaction in LinkedIn and our LinkedIn groups, etc. Lots of different avenues and ways that we can reach our users, including, of course, the smart manufacturing industry forums that we have. Next slide, please. Of course, many of you joining us today should be familiar with Mesa, but if anyone isn't familiar with Mesa, Mesa is a nonprofit association made up of members that is advocating for the application, both responsible and secure and profitable, of technology within manufacturing. We've been doing this for a very long time, over 30 years, since 1992. Because it is an assembly and a group of volunteers and members, you can get real practical expertise, practical advice about the current state of affairs and where things are going within technology. This is really the hallmark of Mesa and the content that we provide. This webinar will be a great opportunity for us to showcase some of our members and what they're doing within this space. The next slide, please. A little practical housekeeping. We are in a webinar, and the webinar is hosted by this Zoom webinar platform. So as you're joining, you should be able to change your audio settings. You should also see in the toolbar the ability to use the chat. You should have at the bottom of your toolbar again, you should have a button that shows raise hand if you're interested in asking a question. We ask that you keep your questions in the midst of the webinar down to the minimum so we can maximize the time to provide you the content that we need. But in the Q&A button, which you also have, you can post a question and we will address as many of those questions as possible at the end of the webinar. And with that, I want to turn it over to Jill and Oscar and give them an opportunity to show you what they've been doing at CDW. Thanks, Jill. Thanks, Oscar, for joining us. Really appreciate it. Some great content that we're going to be able to showcase to folks here today.
Thank you, Chris. We're happy to be here. Couple things on our agenda today. We want to talk about some of the challenges that we see in the OT space. We want to briefly touch about some of the planned investments that we see partners making. We're going to talk about OT versus IT and how it affects things like security, AI, data, ops. We're going to briefly touch on market trends and success strategies, and then we're going to talk about our secret sauce, which is our transformation roadmap. We talked about who I was a little bit. I've been in this space for about 18 years. I've ran our IoT business and emerging tech for the last 6. So happy to be here. Oscar, let's introduce you.
Oh, okay. Well, I've been in this business for over 25 years, probably a little longer than that. And then on the bottom, you see all the different companies that I dealt with throughout my career. I've been in automation for the most part, but I have flipped back and forth between automation and IT. So, it's a great kind of a flip flop kind of thing. Not to make a reference to logic, but
Awesome. Thank you, Oscar. All right.
welcome.
Let's start with some of the network challenges that we see. One of the common threads that we'll see throughout this entire presentation is that the need to make this environment reliable, adaptable, and sustainable. So if we start with security threats, some of those stem from legacy systems. We see increased exposure, especially with IoT assets or assets being added to this new OT network. Integration complexity is a challenge as well. Integrating the OT and IT with multiple protocols. It'd be nice if we had one or two or maybe three, but there's a ton out there. The other challenge we see is that future tech needs have to be adaptable, have to be reliable, have to be sustainable, have to be all those things. So you have to be a little bit looking forward to see what's coming. Outdated infrastructure. This is a challenge because it requires an investment and there's significant budget planning that has to happen. The other thing that happens with this outdated infrastructure is that as you do upgrades, as you know, it's an always on priority. There's no shutting the lights off. It's got to be always on. Scalability limitations, expanding these networks is also investment planning, and then real-time data processing needs. So you need a network that's got high reliability, low latency, and some of those things require upgrades. So those are some of the major challenges that we see in this space today. Where do people want to invest, or where do we see our partners investing today? If you look at this list, once again, adaptable, reliable, sustainable. These are in the next 12 months. Digital twins is at about 15%. IT OT integration through a platform is our number one at about 19%. IT OT integration through data, that's pulling data from those assets out there, is about 15%. Digital workspace, we're seeing AR, VR, MR, all those digital twins or digital workspaces starting to grow as well. ML, edge devices and computing. So you can see this chart also talks about what we see in the next 12 months, what we see in the next 12 to 24, and then what 2 to 3 looks like. We also see this market changing rapidly, so this chart could be completely different next year as well. All right, let's talk about OT versus IT. Oscar, you want to take the lead here?
Sure. So basically, when we talk about IT and OT, we're talking about two different worlds. For the most part, OT has been sort of a silo environment. The type of equipment that is used is completely different than the type of things that we have. And then the business expands in a lot of different areas. So you talk about manufacturing, mining, oil and gas. It's a completely different environment, and the type of equipment that is necessary for each of these sectors is different. There's also a lot of robotics that goes on. There's a lot of industrial controls and supervisories, as well as all the SCADA systems that come from the past. And the PLC is still sort of the backbone of every manufacturing that is there. That is every manufacturing process that is there, along with the CNC machines that make up all the parts. These are some of the examples there are. Now, when it comes to data, the type of data that comes is basically completely different because it's a time series data. So it's data that comes with a timestamp from sensors and so on, and it's providing information in real time about what's going on in your process, about all the different parameters, right? So we're talking about, it could be speed, it could be temperature, pressure, vibration, it could be a lot of different things that you're measuring along your process in a facility. So that's kind of the difference, right, between the two. So we can move on to the next slide, I guess. And what I try to do here is I'm trying to compare sort of what goes on in the IT world versus what goes on in the OT world. So if we start with security, the primary goals of the two is completely different, right? In the IT side, you're trying to make sure that you protect the data that you have, and the applications that you have to run your back office, right? On the OT side of the house, you're worried about physical operations and safety. Okay, so because there is a consequence, there's a physical consequence out there. The key assets are completely different. You're talking about data and applications and network infrastructure, so to speak. On the other side, on the OT side, you have industrial control systems and physical equipment that is actually moving stuff and doing stuff out there. The top priorities are different. Confidentiality and protection, I guess, is on the IT side. And on the OT side of the house is availability. You want to keep that line producing, right? The systems involved are different, right? You have sort of a standardized set of systems on the IT, right? You're looking about standard operating systems with, servers and databases and so on. That is pre-standardized. On the OT side, you have PLCs, you have SCADA systems, you have motor controls, you have all kinds of different things, actuator controls, and so on. So it's a very different environment. The threats are also different, right? For the most part, you're looking at malware, ransomware, and data breaches on the IT side. And on the OT side, you're looking at disruption, physical damage, and safety risk. Right. So you're looking at someone, for example, trying to get into a water plant system and changing the chemicals that go into a water plant. That's a safety risk. The protocols on the IT side are pretty standardized. So the ports, everything is pretty much well known. Whereas on the OT side, you have a lot of systems that have been in operation for over 40 years. And these systems have a whole variety of protocols. Even though the protocol might be the same, there might be several different instances or implementation of the same protocol. And therefore, you end up with amalgamation of things that are kind of very customized from manufacturing to manufacturing plant. And a lot of proprietary protocols as well. The tools, basically on the IT side, you're looking at incident response, management, and firewalls, and endpoint protection. And on the OT side, you still have the firewalls, but you have a threat detection system, and you also have a network segmentation. So those are the three basic things. So, and then the standards are very different, right? GDPR, ISO 27001. And on the IT side, on the OT side, you basically have IEC 62443, NERC CIP for the grid, and then you have NIST 800-82, which is sort of a compilation and also includes some of the IEC 62443 as well. Next slide. Okay, so if we look at AI, the implementation of AI, again, this is very different. In a sense, there are some differences and some similarities, right? Primary goals, you're trying to automate the tasks and the productivity that you have with the tools, right? So, sort of like you have spell correction, that type of thing, or you have dictation that you could do, right? So those are back office processes that you could do. Well, on the manufacturing side, you're trying to optimize production, improve quality, and ensure safety. So you're trying to do all those three things. And they're all related to each other. So if you improve quality, you might not be able to produce at the same speed, and you might have safety issues. So again, this is the type of things that you have to deal with in the when you apply artificial intelligence to manufacturing. The use cases in IT are basically related to customer service, finance, automation, document processing, HR, all those type of things that you normally see. Whereas in manufacturing, you're trying to do predictive maintenance, quality inspection, and process optimization. Very, very, very different. The data structures are, again, very different, right? For the most part, you're looking on unstructured data, emails, financial records, et cetera, on the IT side. On the OT side, you're looking at basically, time series data, like sensor data, images that are timestamped, structured production data, from an OPC UA, for example, that gives you the relationships of all the different equipment in the production line. So it's very different. The response time for the most part, is non-critical, right? There are some real-time things that you have to do in customer service. Obviously, you can't just sit there, even though we sit there in the chat and we wait forever. So we don't think it's real time either. But it doesn't create an issue of safety unless you're calling a 911 or something like that. In manufacturing, real time is critical, right? Because if you delay an action, that action has a consequence that you didn't take. And that could be an action that can create a hazard. And the types of key technologies are also very different, right? You got character recognition, large language models, those type of things going on the IT side. On the OT side, you're looking at computer vision. You're looking at predictive maintenance, acoustics. You're looking at vibration, and you have edge computing in order to do all this stuff, because it's got to be real time. So you can't just take it out of the factory. The challenges also are different, right? Privacy, software integration, and employee adaptation is sort of like what you see in IT. In OT, you got legacy systems, data and quality and safety standards. So it's very different. In terms of like the legacy systems, you might have a manufacturer that have grown through acquisition, and they might have 5 or 6 different factories, and all those factories are completely different because they purchase it from different providers, from different companies, and therefore, even though they might be producing the same thing, the way that they produce it might be different from factory to factory. So that's very challenging. The impact is that you want to increase efficiency and improve customer service, and you want to be strategic and focus in the IT side, right? On the other side of the house, you're looking for productivity, quality, and safety. The same 3 things that we keep talking about, right? We started with quality, productivity, and safety at the very beginning. We're still talking about that. It's all about those 3 things. Compliance, you have GDPR, you have SOC 2, and on the other side, you have ISO and IEC, for example. So next slide is we're going to look at the data, the type of data that we're using. The type of data that we're using on the IT side is basically to try to enhance productivity and support automation, right? Again, I go back to my spell checker, right? That's sort of like one of the things that you want to try to do. You want to increase productivity just so you have something that checks your spelling and makes sure that everything is correct. On the other side of the manufacturing, we go back to the same thing. We want to optimize production, reduce downtime, and improve quality. Those are the goals always. The types of data we're looking at: financial data, HR records from the IT, forecasting, customer service data. The type of data that we have in manufacturing is sensor data, which is again, it's time series data, production metrics, and also maintenance records for what's going on in the production line. The type of users you have on the IT are basically your finance, your HR, your customer service, your admins, and so on. On the manufacturing side, you have operators, engineers, quality managers, and automation engineers as well. The type of tools and access, you basically are using BI, data lakes, and collaborative platforms. Where in manufacturing, you're kind of looking for real-time dashboards. You're looking for edge devices. You're looking for predictive maintenance. So it's more of a real-time type of environment. Again, the security concerns is On the IT side, you're looking at privacy laws, you're looking at RBAC and encryption. On the OT side, you're looking at segmentation, OT security, and safety standards. Very different than, again, on that side. The challenges on the IT is you always have the data siloing team where, data is not shared. You also have data literacy, and you have the quality and change management. On the manufacturing side, the biggest challenge is all the legacy systems and the data volume and the technical skills. And there's also cultural resistance to change, right? God forbid you tell a production engineer that he's got to wait to install a managed switch where he has an unmanaged switch that he can install and continue production. They're going to install the unmanaged switch to continue production no matter what, right? So that's a rub because production is actually their number one goal. The impact is to try to streamline the processes and try to make decisions easier for people to make, and also to have cross-department insights, right? On the IT side. On the OT side, you're looking at efficiency, but you're looking at efficiency from a production perspective. You're looking at product quality, and you want to do proactive maintenance. Next slide. So when we talk about operations, the primary goal is fast and reliable software delivery on the IT side, right? DevOps, right? On the other side, you have MLOps, which is reliable deployment and maintenance of ML models. The teams involved are completely different, right? We're looking at developers and operational people and QA and security on the IT side. On the OT side, you have data scientists, you got ML engineers, you got data engineers, and you got operational automation people, because you are basically trying to simulate something that is happening in the physical world somehow. So you've got to create models for that. The core processes is continuous integration and continuous delivery and infrastructure as a code in IT is completely different for OT. It's model training, versioning, and development and monitoring. And the reason that you have to do that is because no model is perfect. So with time, you have to continue to improve on your model. It's a continual improvement. So this is why when you do version control, you're looking at code. And in the MLOps side, of course, you're looking at code, but you're also looking at the data models. Because, and the data and the models, and experiments, the three things. Because what's happening is that you're beginning to understand the type of data that you need and the type of structure that data needs to be in. Maybe when you started the modeling, you didn't have all of that. So therefore, as you acquire more data, your models begin to change because now they can get better because they have more data to process and they can get closer to what's happening in the actual manufacturing floor. And that's where the experiment comes in. So when we talk about tools, Docker and Kubernetes are very typical. Docker and Kubernetes are also part of in manufacturing as well. But the type of tools that you are using are more tools for developing the modeling mechanisms to be able to do, again, to be able to take data sets, model, and test. So it's a different flow. And the monitoring is also a little bit different, right? You're looking at systems and application matrix, right? In the IT side, how well you can process data and how quickly the people that are using that data they can take advantage of it. On the MLOps side, you're looking at the model accuracy. You're trying to detect drift, and you're trying to do training all the time. So you're retraining your model as your data gets better. And I think this is it, right?
That's it, Oscar. Well done. I
Okay.
think those charts are great. I love the way that they compare both areas, so I just think that's great. Next up, we're going to talk about some market trends and success strategies. You know, as Oscar talked about the convergence that comes between those two systems, I like this chart. What's happening is that we're seeing IT principles, technologies, and security practices come down to OT, and OT is kind of going the opposite direction. So if you look at the bottom there, we're starting to see hardware software decoupling. We're starting to see a little bit of virtualization. We're starting to see advanced computing become more IT-like. And so when those two things meet in the middle, you have IT, OT applications that are often at the edge. Sometimes those OT apps are in the cloud. We're seeing IoT everywhere. If you look at the data, we're seeing different protocol converters. We're seeing message brokers. We're seeing digital twins. We're seeing IoT data integration. And then the skills is another thing that we briefly talked about. The collaboration between IT and OT is now becoming a one team thing. Cross-domain training, and then interdisciplinary hiring to make sure that you've got skills on both sides of that. So those are some of the things that we're seeing. If we look at additional use cases that we're seeing customers implement and how they're using emerging tech, the first one here is real-time analytics and insights. And so back to what Oscar was talking about, manufacturing operations. How do we enable data-driven decisions to make continuous improvement? So we're starting to see people and things we're using for analytics and insights. Worker safety and compliance. We see IoT wearables and sensors to monitor that safety. Are they wearing their PPE? Are they got the right shoes on? Are they in the right area? Are they in the right section? We're looking at predictive maintenance. How do we predict the failure before it happens? What we typically know what that machine does. It starts to vibrate, it starts to heat up, and how do we, use sensors to enable that so that we can have better predictive maintenance? Quality control and insurance, obviously, sensors to monitor that those parameters and when they get out of spec. Remote monitoring control, supply chain optimization. Asset tracking and management. Where are those assets? Did they get returned? Are they in the right place at the right time? Everything from a wrench to a box to whatever you can imagine. Inventory optimization. How do we look at real-time inventory tracking? And then energy management. We're starting to see this one take off. This is something that's part of Industry 4.0. We'll talk about it here in a minute as well. So we've talked about the convergence, some of the trends, and so the next format of these slides, we'll talk about the trend, and then we'll talk about the success strategies for you to get to those trends or to adopt those trends. And so this one basically just talks about the convergence, and it's the goal there is to improve the data sharing and operational efficiency. So success strategy number one, look at a standardized framework such as IEC 62443 as you bring those groups together and make sure that that helps with the integration. Security protocols and network segmentation, this is essential to protect that OT data from IT security risks. And then cross-training, make sure that both of those resources are an effective way to reduce the knowledge gaps and they know the art of the possible on both sides. The next thing here is edge computing. We're starting to see this grow. Right now, the last number I saw was about 34.1% compounded annual growth rate in 2025 for edge compute. So more OT networks are using edge computing solutions to process that data locally. They do that so they can reduce the latency for real-time operations. Some of the success strategies that we've seen clients adopt, identify high priority processes. Where do those real-time analytics need to happen at the edge, and how can we improve our outcomes by having that compute at the edge? Categorize machines based on business impact. Is this a SEV1? Is this a SEV2? Is this a SEV3? How does this financially impact our customers? We've talked to clients and they've said this is a challenge for them. And the reason it's a challenge is because they don't understand the financial impact of that system going down. And so what happens is they begin playing whack-a-mole, trying to figure out which one to troubleshoot first. And so the point here is categorize them, know where the ROI is, know how it impacts your line, and then prioritize your tickets based on that. Modern design and security measures from the edge to the core data center to the cloud. You've got to manage that data all the way through the process. Oscar, you want to take this one?
Yes, sorry. There's a little delay here in my mute button. Okay, so cybersecurity is actually one of the one of the biggest issues that we see nowadays in most manufacturers. I mean, one of the things that are kind of forcing that is cyber insurance is beginning to look at what is the potential effect of a cyber incursion into a manufacturing plant and what does that cost. I think that the last time that I looked at a number, the average cost is about $4.9 million. And it's important to understand there's two things that have to be taken care of, basically, when you're looking at cybersecurity. One of them is to have some type of zero trust security model for your remote users. And what I mean by that is we're talking about the integrators that are basically logging into your machines remotely, and they're making changes to that PLC, or they're making changes to that firmware. And to have the ability to control how those integrators or automation engineers that are not employees, but are basically doing the support for your production line, how do they access your systems and what type of controls do you put on that? Okay, and then the other part is to have real-time threat detection and response tools to quickly address any potential breaches, and then try to ensure compliance with the IEC 62443. And of course, the first thing that you got to do is you also have to do an audit of your system. Understand what is in your network. I mean, part of the problem is that unless you do an audit of some sort, you're not going to find out. And this is what these tools do. All these monitoring tools are passive monitoring tools with some minor querying capabilities that they use in order to gain all the information about the assets, like what model PLC you have, what type of NIC cards are in it, what are your IO cards. And then at the same time, they will provide you with the vulnerability list against that particular firmware version. So understanding what you have and how you're vulnerable, that's the first part of it. And we know that you cannot always patch, right? So sometimes you have to kind of live with on systems that cannot be patched, either because they're obsolete or because they're in production 24/7 and you can't stop production to patch, and you have to wait for a maintenance window of some sort. So segmentation is your friend. So that's where 62443 provides you. It's a framework for figuring out how are you going to segment your network. It's not a prescriptive, but it's more of a sort of a roadmap of how you should think about your network and how to segment your production devices, right? Some people do micro-segmentation, where they basically are segmenting one whole production line, and then they segment production line from production line. So therefore, if you have an issue in one side, it doesn't move laterally to the other side, to the other production lines. That's one of the first steps. But you can also do micro-segmentation within that production line as well. So that's basically the trend here, is to make sure you do an audit, because more than likely your cyber security carrier is going to ask you to do one.
Awesome. Thank you, Oscar.
Sure.
The next trend we want to talk about is the industrial IoT is expanding within OT networks to provide a new insight for process optimization. So what we're seeing here is adopting IoT platforms that integrate with specific OT protocols like Modbus or OPC UA. The next success strategy there, analytics. Make sure you have those to turn that data into actionable insights. It's one to get the data. It's another thing to have actionable insight from it. I encourage you to build partnerships with solution providers. It's important to have access to the latest technologies and support that's out there. We are standing at a point right now where this is the least amount of change that we'll probably see for the rest of our lives. So I think those partnerships can help and add value there. The next one is we're seeing a strong growth pattern in predictive maintenance and asset management. Many organizations are using IoT sensors within OT networks to enable that predictive maintenance. Some of the success strategies we see: deploying smart sensors and IoT devices across critical assets to collect data in real time, utilizing AI and machine learning algorithms to predict failures and schedule maintenance efficiently. We actually had a partner of ours that asked us to come in and talk about how do we help our clients. They were building a manufacturing machine, and they said, how do we help our clients integrate and align their predictive maintenance schedules based on the sensors that we have in our machine? So we're starting to see those two worlds come together. Integrating predictive maintenance data with enterprise asset management system also allows for better life cycle management and resource planning for maintenance. So we see that as something that's up and coming as well. We're also seeing a little bit of a shift towards cloud-based OT solutions. So as cloud computing matures, more OT networks are connecting to the cloud for scalable storage, remote monitoring, analytics. So non-critical data processing and storage to the cloud can help free up some of those local resources and improve accessibility. Another success strategy is look at hybrid cloud architectures to allow for local control over critical processes. We're actually been seeing these processes get split. So you'll see a immediate processing at the edge, and then they'll send it to the cloud for further analytics. So it really depends on what you're solving for to choose that. And then also compliance with data residency. Where does that data reside, and make sure that you're in compliance there. So this wouldn't be an emerging tech presentation without talking about AI. So obviously there's a rise in AI. We're starting to see this more and more. Success strategies: identify the use cases. Where can AI ML yield measurable improvements such as energy optimization or fault detection? But having those use cases and having goals, I think, is a great place to start. We'll talk a little bit about our secret sauce and how we help customers do this. The next thing there for success strategy, skills gap. We're seeing a big skills gap in the OT teams to understand AI and ML, and so getting training for those folks is extremely important. Also, in order to bridge that gap immediately, partner with technology providers so they have access to the AI tools and support that you need to be successful. So those are two things I think that's great to start with. Data standardization and interoperability is another trend that we're seeing. With more and more data sources across that environment, organizations are starting to focus on this, and they want smoother integrations. So the first strategy is adopt a industry standard protocol and formats to ensure compatibility across all of those. Middleware solutions that can pull that data from those sources, and then unifying those data standards across IT and OT. That's part of the challenge, that there's not a single standard. So think about how do you unify that, and how do you have an ecosystem that works well together. The next one here is increased focus on energy efficiency and sustainability. We're seeing this go as a means to ensure customer satisfaction. We're seeing more green initiatives happening. One of the core goals of Industry 5.0 is sustainability, including decarbonization and driving increased regulation within the environments. So some of the success strategies here: implement energy monitoring systems across your OT assets to identify and reduce that excess consumption. Also, automation to reduce energy. How can you automate a process to reduce energy? Looking at non-peak hours, resource allocation, resource utilization, all those things come into play. And then also seek out suppliers with energy efficient equipment and prioritize sustainability in procurement decisions. So those are some things that are critical to making that a success. I smile when I saw this chart come about. I used an AI tool to help put graphics in here. When I saw this picture come out, I thought, what are we doing? Where are we going here? And I thought, you know what? This is part of being flexible. This is what it is. And so the trend here is OT networks must be adaptable to changing demands and new technology integrations, such as AI building your PowerPoints. But the challenge is that it's coming at us so fast, you really have to think down the road. You really have to think about what are some of the blind spots that we may have as we do this digital transformation. So software-defined networking, we think that's essential for building scalable and flexible OT networks. Scalable edge solutions that can grow within the operational needs. So make sure what you're looking at is scalable and flexible because it will change tomorrow. It will change the next day as well. Here's one last slide on why we think this is critical. And so this is kind of what it looks like from top to bottom, from shop floor to top floor. These are the changes that we see across those areas. And so if we start here in the bottom right, operational technology is often the start of this. And so adaptive and machines and robots, we're starting to see those environments change. IoT edge is changing, automating work centers, operational control, digital mock-up and simulation. Those are some of the things that we're seeing at the shop floor. And as we work all the way up to the top and the top floor, it's co-innovation, it's co-creation, it's operational visualization. All these enterprise systems are starting to integrate together, operational intelligence. And so they're all connected from the shop floor to the top floor. And so the key role to make this happen is the CIO. No one person on the shop floor is going to say, you know what, I think we should do this digital transformation. That's not the right resource. And so the CIO has to be involved. They have to be a strong agent across the top floor, across all those organizations. They have to be a change agent and enabler in the control room, down on the shop floor. And then the speed of industrial data delivery is also important. How quickly can we get those data in that inside out? And so some examples, Gen AI requires IT, OT architectures. And so data producers, data collectors, they're all in different areas within the organization. And so the point here is that the CIO is critical to make this transformation happen, to make it adaptable, reliable, sustainable. All right. Let's share a little bit about our secret sauce. We have seen the same challenges happen as emerging tech, and we look at companies and they come to us and they say, you know what, I want to transform my business, but I don't have the skills I need. And so I want to know, you know, what do you think is the best thing? They're not familiar with what's out there, and rightfully so, because there's so much emerging technology. If you look back to 2013, I think the number of unicorn startups we had was like 31. And if you look today, there's like thousands of them. And so it's coming very fast. 26% struggle with where to start. What's the right thing to start with? And so about 9 years ago, we built this transformation workshop. We've put it in front of multiple vendors and multiple partners and said, how can we make this better? Every year we make improvements to it. But what we found is that we get asked the question, Jill, what do you think we should do? Where do you think we should start? Can you give us some use cases? And my first answer is, what are you solving for? And so we go back to, what are the business goals you have? What do you want to do with your business? How do you want to transform? So we start with 4 business goals. We look at value drivers. We bring in 10 people from your team to say, how do we meet those goals? What ideas do you have to transform your business? We then prioritize that list. In some cases, we get 160 different ideas. Nobody's going to implement 160 ideas. And so we say, what are the top 12? So we look at the top 12 and we say, for those top 12 that you have voted on as a team, what's the business process associated with that? What's the business systems that data flows through? We then look at the data and say, how much of this data that's coming from this new idea is relevant? How much of this data is revenue? How much of this data can we shave off at the edge and don't pay all the way through, you know, the system to the cloud? So we look at all those different things. We also look at systems as systems. Are there things outside of your environment that you need to pull in to make this solution work? We do a 9-point technology gap to say, for this technology, you need to add, improve, replace, or keep each piece of the reference architecture. We look at IoT technology and then security as well. And so we do this in about a day and a half. What we found is that most clients don't have the time to do a 6-week engagement. That's $600,000. So we've pushed this down into a microservice. It's about a day and a half, takes about a week to deliver. We average about 85 different ways to transform businesses. We typically charge about $30K, and the ROI is in the millions. And so let's talk about that a little bit more. This is our focus. This is why we get brought in. So customers come to us and say, I've got financial challenges. I've got operational challenges. I have some things I have to do better for my client, or there's government mandates or sustainability or missions that need to be met. And so these are the things that we often get brought in to do this workshop. This is a business first, technology second process. So that means that the primarily people that are sitting at the table for this workshop are your business leaders. So facility manager, safety official, director of operations, those are the folks that we often invite to this. One of the first things we do is we talk about the revenue structure. We talk about how do you make money in your environment? How do you lose money? What are your current challenges? What are your future challenges? Where do you want to grow? What are some of your competitor insights? What are some of the industry trends? And then we also talk about your assets and what you're most proud of. Secret answer here, the asset question, the answer is always data. So if I ask you what the most valuable part of your company is, the answer is always data. This is what we do for the top 12. We call this our cut sheet. And so we go back and say, what was the goal? Our goal for this particular client was improved supply chain optimization. The business area that is affected by this idea is plant engineering, supply chain, manufacturing. Some of the benefits, why would we do that? We list those out. We also say, what was the priority? What was the vote? How did this rank in the top 12 projects we have? We then we have a formula, an algorithm that we run for technology gap. We also have an algorithm that we run for complexity index. This looks at how complicated is it? How many systems are you integrating with? What's the skills gap? All those things go into our complexity index model. We also ask you, is it a cost avoidance scenario or are we increasing revenue with this idea? And if so, if it's either one of those, how much? And so this particular client said this is a $10 million estimated annual impact. In year one, after we implement this, they think it's $10 million they can change their bottom line. So we talked about what are we sensing? Is it vibration, image, temperature? This particular client had all of them. Insight response time, what are we integrating with? What are we trying to determine? And then what action do we want to take once we have that insight? Across the middle here, this is the gap analysis. Like I said, we ask, do you need to add, improve, replace, or keep this component to make this work? Across the bottom, one of the challenges that we saw that people often had was that the use cases, they didn't understand the data, they didn't know where it came from, they didn't have all that together before they did their launch. And so they often had to start, stumble, and stop because they didn't know what this was. And so we talk about that. Who else in your company can use this data? In most cases, this is a new data set that wasn't available before. And so we ask, who's the person? What's the persona? What's the use case? And so we map those out to make sure that we've got everybody covered. These are some of the things that come on the output report, just executive summaries, technology gap and complexity index. We basically chart all of your ideas so you know which ones are high complexity, high technology, which ones are low hanging fruit. Across the bottom here, we take the top 12 projects and say, what's the technology gap across all of them? So for this particular client, networking, 100% of them needed to improve networking. Storage, 90% of the top 12 projects needed to improve storage. So you can kind of see how that works. So just to summarize our presentation here today, we've got a few minutes left for questions. One, adopt a standardized framework for integration. We talked about 62443. We talked about how to bring in that enterprise network to the industrial network. Upskill both teams. You have to have both sides understand and provide a productive relationship between IT and OT. You have to foster a culture of innovation. You have to get people to understand it's okay to question things. It's okay to bring up ideas that talk about how can we use this data or this insight to improve operations. And so that culture has to change in some cases. Improve visibility and security. Make sure your OT infrastructure is deployed. Make sure you have a dynamic list of assets. 55% of organizations don't have an inaccurate or no asset list at all. So we don't even know what's in this environment. The last thing, build a flexible, scalable network. Sometimes this is a network upgrade. Modern, agile, managed, and secure wired and wireless is important. And then we also talked about digital blind spots. What are the things that are coming down the pipe that may impact our network, our environment? So I believe that's our last slide. So with that, let me stop sharing and say, what questions do we have?
We did have a question. So first of all, Jill, Oscar, thank you very much. That was incredibly insightful. Having talked to you and prepped for this presentation, I knew that, aside from just being technology experts and also suppliers in the space, you also had tremendous insight about where people are struggling, where their pain points are, and a methodology that you could present in order for people to understand, how do you start? Where do you begin? How do you assess? How do you get your arms around something so big? Multi-year investments that touch so many different parts of operations may even affect things that you hadn't considered. So just very insightful. Thank you so much for that. I know there was at least one question that came through that, Oscar, you threw a response to, but if you would like to address that in a more open form for everyone, that'd be great.
Sure. So the question was, what type of tooling are we seeing for microsegmentation and device discovery in the space? So basically, the tools that we see are specialized tools. So we see tools from Nozomi, Clarity, Cisco Cybervision, Tenable. There's others, ORDR. There's quite a few of these manufacturers that make tools for this, and they all basically work in a similar fashion. They monitor your OT traffic. They try to figure out what is the relationship of the conversations that are taking place, the sessions, right? Like an HMI talking to a PLC or vice versa. And they basically create what is called a model for your standard traffic. And based on that, they begin to detect anomalies. So if all of a sudden a device, a PLC that never talked to an HMI in a completely different segment is trying to do that, you have to question yourself why. And this is detected as an anomaly. So this is sort of like one of the things that they do. And then that also helps you in the segmentation purpose, because now that you know how all the traffic is flowing, you can much more easily do the segmentation of all your device, your network, based on the traffic flows that you detected.
Excellent. And I was thinking along that when I saw that question pop up as well, just as a follow-on, Oscar and Jill, are you seeing, in the IT space, it's much more common today to see remote monitoring and management? Think dashboards and consoles, war rooms where you can monitor these things proactively and see the alerts. I would imagine that the list of vendors right there, as you pointed out, it's not just discovery of those assets, but the constant and continual operational monitoring of them and the creation of the equivalent of an RMM in the OT space. Right,
Right.
So that you can react immediately. You can isolate, shut down, as you pointed out. When you have segmentation, it's not just that you know that this is happening or that it's uncharacteristic, but you can isolate it because you have a good network architecture that can allow you to do that. So, excellent.
Yeah, and we're also beginning to see managed services for OT. This is one of the things that we are going to try to bring out to the market, just like we do for IT. Right. So instead of having to, because part of the problem is, by the way, this is an interesting question, because part of the problem is making all these technologies operational. Because as soon as you bring up one of these technologies, you get to see everything that is on your network and you're overwhelmed with data. And the issue is, okay, where do I begin? Where do I start? That's operational, putting these tools into operation and stabilizing your operations is the hardest part of the whole process.
This is where, in today's world, and again, with the tool sets that you talked about as examples, they're applying, and a lot of vendors are applying AI now to be able to sift through that data. So it's just another one of these data volume issues where the AI can help us actually to curate that data and bring to the top of the heap the things that are most important and relevant for us. You had mentioned also, in the idea of a managed service, actually, the idea of being able to do that in OT. I'm thinking that one of the things that's always been brought to my attention that's unique in OT is patch management. And it's twofold, right? Obviously, you have criticality of systems. They can't just be patched, through a web or a standard vendor provider like Microsoft would patch your OS. But you also have a lot of very unique pieces of equipment and firmware that also have to be their firmware has to be validated. What vulnerabilities to all these different vendors you have there. So patch management in that MSP space has got to be very complex within OT and very unique, I would imagine.
It is super complex. But by the way, one of the things that is happening, it's one of the trends that I see is that there is usually patch management happens through remote access, right? So there's usually an integrator that remotes into your machine,
Mhm.
right? And it does whatever update needs to happen at that time, right? So what the new tools for remote access are doing is they're tracking that session, right? They're recording that
Yeah.
whole session. So now that piece of data that said you patched this piece of equipment gets recorded. And now that can be also used with your monitoring tool
Mhm.
that basically prior to that was identifying that device that's needing a patch. So now you kind of begin to see there's this kind of integration of those tools is going to happen at some point in time. And also it's going to detect if there's other devices in your network
Yep.
that are similar that detect the same patch. So now they're going to be able to say, hey, listen, you need to go. This also needs to be patched in case you forgot.
Yeah, exactly. I have 100 temperature probes out there.
Exactly.
They're smart probes, and I've patched 5 of them, but the rest of them on the IO-Link network, they're still in the candidate list. So exactly.
And
Perfect.
by the way, here's the patch because
Yeah.
now you got it because you recorded it.
Yeah. Perfect.
So
Excellent. Folks, I want to thank everyone for joining us. Again, as I mentioned a bit in the top of the hour, I know everyone's time is valuable, but I hope that everyone thought that this content was extremely valuable. I know I learned a lot listening to Jill and Oscar, and really appreciate the time that they put into to bring this to all of us. Any parting thoughts, Oscar, Jill? I don't see any other questions.
None from us. Thank you for the opportunity. We appreciate this. We see this as a very interesting space, and we're happy to be a part of the growth of it. So thank you again for inviting us.
Absolutely. Thank you so much for participating, and thank you for adding to the collective knowledge of all of us here at Mesa. So with
thank
that,
you.
I'd like to conclude this webinar. Thank you very much again for joining us. It is recorded. It will be available later via a link. The slides will be made available. Abigail and the team back at Mesa will make that public to all the members and let them know where to find that. So,
Okay.
okay,
Thank you all.
perfect.
Thank you all.
Thanks so much. Have a great rest of your day.